All right, welcome to part 3. So we're going to keep on doing problems. This one's actually very similar to the last one. We're given that log of x equaling 2, log of y equals 3. Since, again, there's no base written, we take it to be log base 10. But over here on this side, when we use the rules, we don't need that. Okay? So we're going to evaluate log of the fourth root of x cubed y to the fifth. Now remember, fourth root is the same as the power 1 to the fourth. Okay? Fourth root is the same as the exponent 1 to the fourth. Now this 1 to the fourth can come in front. That's what we do in the first step. This 1 to the fourth is the same as that 1 to the fourth. That's from one of the log rules. Now, the next step, we have x cubed times y to the fifth inside a logarithm. That means we're just going to add log of x cubed, log of y to the fifth. Okay? Again, powers coming in front, or exponents coming in front. So this 3 becomes that 3. This 5 is that 5. Now we were given, way up here, log of x equaling 2 and log of y equaling 3. So log of x equaling 2, log of y equaling 3. So we get 1/4 times 6 plus 15. 6 plus 15 is our 21, and divided by 4. Okay, so that was using the rules. Now we can do it directly as well. Okay, I'm doing it quickly up here. Log of x equals 2. Well, that's equivalent to saying x equals 10 squared, which is 100. Log of y equals 3 means y equals 10 to the third, which is 1,000. So we're going to take log of the fourth root of 100 cubed 1,000 to the fifth. And if we calculate that, we're going to get 5.25, which is the same thing as 21/4. Okay? So this is really, again, like the other way. This is the expected solution. Because I could trick you by saying log base a of x equals, let's say, 2, and log base a of y equals 3. And now we no longer can say what, we no longer know that x is 100 and y is 1,000. Okay? So I'm not going to do that, but that's something that you guys got to keep an eye out for, just in general. Okay? Let's do another problem. We're going to expand this expression. We're going to expand this expression. Now, remember, when you multiply inside the logarithm, you add them. And when you divide, you subtract. So everything in the numerator gets added, and everything in the denominator gets a subtraction. Okay, so the x plus 9 squared, that's a positive. That's in the numerator. Cube root of x plus 5, that gets a positive. X minus 7, when you take this and expand it, it's going to get a negative sign. Even though these are multiplied together in the net, the square root of x plus 8 is in the denominator. So we're going to make that a negative. Okay. Now, remember our little exponent rules for roots. The cube root means you're taking to the power 1/3. The square root means you're taking to the power 1/2. So, putting the exponents in front, the 2 goes in front. The 1/3 goes in front here. Here, there's no power to speak of, so we just leave it. Here, the 1/2 goes in front. So this is the expanded form of this expression. Okay? This is often useful for calculations, particularly if you're going to be taking calculus next semester or next year. Okay, there's also the opposite. We could condense an expression. We could condense this expression. Okay, 1/5 log base 8 of z plus 2/5 log base 8 of y. Now, doing the opposite. We're taking the 1/5 and putting it on the power, just like we're taking the 2/5 and putting it on the power. Okay. Then we're going to say, well, we add logarithms. Well, actually, first thing we're going to do, we're going to rewrite that. That's the 5th root of y squared. Okay, the 2 comes from here, and that's the 5th root. And now finally, taking when you add logarithms together in the same base, that means you multiply inside of the logarithm. Okay? We could have also gone about this another way. We could have said, well, this is 1/5 log base 8 of z plus 2 log base 8 of y. 1/5. We could say, well, you know what? I'm going to go ahead and take this adding of logarithms as multiplying inside the log. Well, I should have done y squared first, right? The y squared goes there first. And then taken log base 8 of the 5th root of zy squared. All right, see you all in the next video.